Today, the first article is Intel details the 14A performance and a new turbo cells that unlocked maximum CPU and GPU frequency. So Intel made a slew of announcements at its Intel Foundry Direct 2025 event in San Jose, California, and finally shared the performance metric for each upcoming the 14A process node, slated in the risk production in 2027, doubting the headline improvement up to a 35% reduction in power consumption. So Intel also teased its new turbo cell technology, a customizable design approach geared to provide maximum the CPU frequency and boost performance and critical speed with a path in GPUs. So the 14 and 14A, 14A and 14AE nodes are the next generation after the company's 18A node. Intel says the 14A will be deliver a 15 to 20% performance per watt increase over 18A, which can be leveraged as either the higher clock speed at 25 to 35% low power consumption and the same performance, depending upon a chip-specific tuning. Much of this improvement is due to the Intel's low direct contact backside power delivery network, which are the company had dubbed the power direct. More here. Then Intel has sprinkled in other new features to improve the node, such as a wider thread voltage range that enables a more expansive voltage frequency curve. So the 14A nodes also deliver a 1.3 times increase in transistor density over 18 node. Intel has revamped the ribbon-fed transistor for the 14A, now known as RibbonFET 2.0. Intel hasn't shared details about the new generation of RibbonFET, but the general design provides improved transistor density and faster transistor switching by utilizing 4 stacked nanosheets around surrounded the entire by the gate. You can see the cross-section in the NMOS and PMOS transistor above. So the turbo cells and critical paths. Intel's new turbo cells are a standout feature, but they are a bit complicated. Turbo cells can be used for a multitude of the purposes, but Intel specifically calls out they will be utilized in the critical paths of the CPU and CPU, often referred to as speed paths, and for a good reason. Timing paths within a processor allow it to let a signal travel along through the wires and logic gate during normal operation. However, delays to those signals can interrupt the clock timing of the processor. The critical paths are those that have longest total delay. Because the processors operate based on clock signals, the slowest critical path dictates the highest path frequency limit of the entire chip. Serving as a part like the overall performance, there are distinctions here for the various clock domains, but the general principle holds true. So the chip designers often use a higher speed transistor in this area of a chip, but this comes at the cost of reduced transistor density and increased power consumption, as faster transistors are leakier and thus consume more power. The new turbo cells provide a chip architect with more refined tools to mitigate the critical paths. So the 14A node features 3 distinct standard cell library, which use process node-specific building blocks. Standard cell constructed with transistor of a pre-designed logic gate and a circuit element. Designers use electric design automation EDA software tools to utilize the library during the design flow and generally lay them out in rows. So the Intel's 14A has 3 different libraries. The tool library has transistor cells optimized for high frequency, low density, and leaky, and the mid-side library is optimized for performance per watt, and the short library is focused on density for area and power sensitivity applications. Intel has not shared density information for various libraries yet. So the short libraries are used heavily in CPUs and GPUs to pack the most transistors possible while keeping power density at manageable level. So that's where the Intel's new turbo cells step in. The turbo cells are designed to enhance performance by increasing the transistor drive current for short libraries when they are used to create double head libraries at the head of the two standard rows, so all while maintaining a high density arrangement for optimal area efficiency. The above graphic represents four different arrangements of NMOS and PMOS ribbons nanosheets, pink and green, with varying width and configuration to optimize the drive current for different scenarios. The width of the ribbons can be adjusted or they can merge independently to create very wide ribbons for maximum drive current delivery. The various options provide designers with a robust toolkit for detailed implementation. So intercells, the turbo cells can ultimately be used to mix in faster and less power-efficient cells with power-efficient cells within the same design block to create the right balance of power, performance, and area (PPA) for any given use case. Critical paths are the ultimate bottleneck. Think of them as the weakest link in the chain. Intel's new turbo cells are designed to boost the overall processor performance by speeding up those paths, but without making the compromises often used to solve the critical path problem. We will have to wait until 2027 to see how the how that pans out. Next one is Siemens Intel Foundry advanced their collaboration to enable cutting-edge integrated circuits and advanced packaging solutions for 2D and 3D IC. The Plano, Texas, USA, April 29, 2025. Siemens Digital Industry Software today announced that its continued collaboration with Intel Foundry has resulted in multiple product certifications, updated foundry reference flows, and additional technology enablement, leveraging the foundry's leading-edge technology for next-generation integrated circuits and advanced packaging. So the Siemens is founding a partner of the Intel Foundry Acceleration Chip Alliance, enabling a new and compelling solution for a 3D IC and chiplet, offering a breadth of the semiconductor market verticals. Intel 18A certification achievement. The Siemens industry-leading caliber nanometer platform tool is now certified for the latest Intel 18A production process design kit (PDK). Intel 18A represents a significant technology leap forward, featuring an innovative ribbon fat gate-all-around transistor and the industry's first power via backside power delivery. This caliber certification allows mutual customers to continue leveraging the caliber nanometer platform tool as their industry standard sign-off solution with the Intel Foundry's most advanced manufacturing process, accelerating time to market for next-generation chip designs. Siemens and Intel Foundry have also successfully certified Siemens Solido, SPICE, and Analog Fast SPICE AFC software tools for the latest Intel 18A production PDK. Both of these tools represent a key element of the Siemens Solido simulation suite software, which is an advanced portfolio of AI-accelerated simulator for intelligence IC design and verification, providing leading-edge, feature-rich circuit verification for analog and mixed signal and memory library IP and 3D IC and system-on-a-chip SoC designs. The Intel 18A process node is now also enabled with the Open Model Interface (OMI), so the industry standard platform the conducting IC aging models and reliability analysis and supported by Siemens Solido simulation suite. So the Intel 18A custom reference flow the enablement, GMS Calibre nanometer platform and its analog fast SPICE AFS software, which is part of the GMS Solid Simulation Suite offering, are also now enabled through the Intel Foundry Custom Reference Flow, the CRF, and Comprehensive Custom Design Methodology Package, and mutual customers can now access the GMS best-in-class simulation and sign-up flow for a chiplet that extended 3D IC designs. So Intel 18A-P and Intel 14A-E enablement. In addition, the qualification of GMS Calibre nanometer platform and solid simulation suite offering for an Intel 18A-P process node is now underway. Customers can request the latest Intel 18A-P PDK for earlier design work and IP development. Moreover, both solutions are part of the Intel 14A-E process-defined design technology optimization (DTCO) with earlier run sets already available. Intel 14A-E is expected to deliver an even higher density and performance per watt compared to the Intel 18A process node. So at Intel Foundry, we were building a strategic alliance with the industry leaders like Siemens to deliver best-in-class design solution to our customers, said Sok Lee, VP and GM of Ecosystem Technology Office, Intel Foundry. So these self-verification and design tools are rigorously tested to harness the full capabilities of our advanced process nodes. As by integrating the GMS expertise with our technology, we were not only streaming the design workflow, but also creating a pathway for our mutual customers to bring groundbreaking innovation to market faster and more efficiently. So advanced packaging collaboration milestone. GMS today also announced the personification of a comprehensive reference workflow, the Intel Foundry's embedded multi-die interconnect bridge T, EMIB-T, whether through the silicon via technology, TSV. The workflow is driven by the GMS innovative 3D IC solution, which provides consolidated cockpit for constructing a digital twin, as featuring a unified data model for design planning, prototyping, and predictive analysis of the complete semiconductor package assembly. The workflow supports the complete detailed implementation and thermal analysis of the die, EMIB-T and package substrate, signal and power integrity analysis, and finally, package assembly design kit, PADK-driven assembly verification. The GMS technology certified in the reference flow, including innovative 3D IC, Calibre nanometer DRC, and nanometer LVS, and the expedition package designers, Calibre 3D Thermal Hyperlinks SIPI, and Calibre 3D Stack. Customers can request the reference flow kit from the Intel Foundry for early adoption and design exploration. So the collaboration has also established the ability of a prototype workflow for embedded multi-die interconnect bridge EMIB technology using GMS Aprisa software. GMS Aprisa automatic place and route APR technology was used to implement the power ground PG grid and a bump routing of the silicon EMIB die. Finally, GMS has joined the Intel Foundry Accelerator Chiplet Alliance, the newest Accelerator Alliance program that aims to define the driver chiplet design infrastructure and in the operability and the security requirements essential to the delivering today's complex systems in aerospace and defense and the commercial markets. So, as an industry leader in advanced package technologies, GMS ED is pleased to serve on an original member of the new Intel Foundry Accelerator Chiplet Alliance, and said Huan C. Ray, a Senior Vice President and General Manager at Caliber Product Line, the Siemens Digital Industry Software. This alliance not only marks a significant milestone in our collaboration, but also brings unparalleled value to our joint customers. Together, we are poised to accelerate the development cycles and push the boundaries of the semiconductor technology, creating a groundbreaking solution that meet the ground demands of the industry. To learn more about the Siemens offering in the integrated circuit and advanced packaging design and verification, visit Siemens Digital Industry Software helps the organization of all sizes digitally transformed using software, hardware, and services from the Siemens Auxiliary Business Platform. Siemens software and the comprehensive digital twin enable companies to optimize their design, engineering, and manufacturing processes to turn today's ideas into sustainable products of the future. From chip to entire systems, from product to process, across all industry, Siemens Digital Industry Software accelerating the transformation. Okay, next one is the Synopsys, Intel, Foundry Propel, Angstrom scale chip design on Intel 18A and Intel 18A-P technology. Synopsys production-ready EDA flows and the broadest IP portfolio deliver a leading PPA for Intel Foundry's advanced processes and packaging technologies. Highlights: the production-ready Synopsys digital and analog EDA flows for Intel 18A and 18A-P technology has paved the way for the broad adoption and accelerated development of the high-performance designs engaged in early design technological optimization for Intel 14AE. The optimized EDA reference flow with a unified exploration to sign-off platform accelerated 2.5D and 3D multi-die designs for Intel's EMIB-T advanced packaging technology. Broadest portfolio of high-performance and low-power IP for Intel 18A and expanded Synopsys IP support for Intel 18A-P offers customers faster times to tape out. So the announced membership in the Foundry Accelerator Design Services Alliance and the new Intel Foundry Accelerator Chiplets Alliance to advance the Intel Foundry adoption and innovation. The Sunnyvale, California, April 29, 2025. At today's Intel Foundry Direct Connect 2025 event, Synopsys Incorporation, NASDAQ SMPS, announced broad EDA and IP collaboration with Intel Foundry, including availability of its certified AI-driven digital and analog design flow for the Intel 18A process node and production-ready EDA flows for the Intel 18A-P process node with a ribbon fed as get all-around registers, architectures, and industry-first commercial foundry implementation of the power via backside power in delivery. To drive multi-die design innovation forward, Synopsys and Intel Foundry are collaborating to enable Intel's new embedded multi-interconnect bridge T EMIB-T advanced packaging technology with the EDA reference flow powered by Synopsys 3D IC compiler. With its EDA flows, multi-die solution, and the broad portfolio of Synopsys foundation and interface IP on Intel 18A and Intel 18A-P, the Synopsys is helping designers to accelerate the development of the highly optimized AI and HPC chip designs from silicon to systems. In a keynote presentation at today's event, John Quester, a Senior Vice President for the Synopsys IP Group, emphasizes the successful collaboration between the Synopsys and Intel Foundry advancing the semiconductor industry with the silicon-to-system design solutions to meet the evolving needs for AI and high-performance computing applications. Our production-ready EDA flows, IP, and multi-die solution provides our mutual customers with comprehensive technologies to accelerate the development of the chip designs that meet or exceed their requirements. Our continued collaboration with Synopsys enables engineering teams to accelerate the system of chips innovation utilizing our unique systems foundry capabilities and optimized Synopsys EDA flow and IP on an Intel 18A and Intel 18A-P process nodes to create differentiated design with a faster time to result. Such Lee, VP and GM of Ecosystem Technology Office, Intel Foundry. Together, Intel Foundry and Synopsys are furthering design, manufacturing, and packaging optimization so our customers can meet the demands of the AI era. Advancing the design innovation with comprehensive EDA and multi-die solutions, Synopsys digital analog design flows are solidified for the Intel 18A process node and product ready for Intel 18A-P, enabling the faster delivery of advanced node SoCs with a higher quality of result. Synopsys IP and EDA flows are also optimized for an area of the Intel 18A and Intel 18A-P process node to take advantage of the Intel's power via backside power delivery network, enabling thermal-aware implementation for power via based design. Ribbon FAT and driven synthesis and optimization enables designers to achieve the differentiated power and performance in area PPA on Intel 18A and Intel 18A-P process nodes. This is the result of an extensive design technology co-optimization DTCO effort between the Intel Foundry and Synopsys engineering teams. The Synopsys and Intel Foundry are now engaging in early design technological optimization for Intel 14A-E to establish the readiness of the Synopsys EDA flow for the next generation advanced node. So the Synopsys and Intel have extended their collaboration to help mutual customers realize the PPA advantage of multi-die designs by enabling Intel EMIB-T advanced packaging technology with the Synopsys 3D IC compiler. EMIB-T combines the benefit of the EMIB 2.5D and Foveros 3D packaging technology for high integrated densities at die sizes beyond the reticle limit. So the EMIB-T reference flow is powered by Synopsys Unified Exploration 2 sign-up platform, allowing efficient EMIB-T design with early bump and TSV planning and optimization and automated UCIe and HBM routing for a high quality of result and a fast 3D heterogeneous integration. So the Synopsys 3D IC compiler allows for feasibility and partitioning, prototyping and floor planning, and multi-physics sign-off in a single environment, so the aligned efficient design creation and implementation, optimization, and closure. So the Synopsys expands the IP portfolio for advanced Angstrom-level designs. The introduction of the Angstrom-level processes will be crucial for next generation AI and HPC chips, and delivering optimized performance and power and area and latency. To accelerate the time to market for these designs, Synopsys is developing the industry broadest IP portfolio for interface and foundation and SLM silicon life cycle management IP on Intel 18A process node, including 224 Giga Ethernet and PCIe 7.0 and UCIe and USB 4 and embedded memories, logic libraries, and IOs and PVT sensors. So the utilizing Intel Power via backside power delivery technology and Synopsys IP will enhance the power distribution and performance and enabling advanced and differentiated chip design with Intel Foundry technologies. So the further strengthening the Intel Foundry ecosystem to accelerate the adoption and innovation, Synopsys is further expanding its collaboration with Intel Foundry and the ecosystem by joining Intel Foundry Accelerated Design Services Alliance and the new Intel Foundry Accelerated Chiplet Alliance. As a member of the latest Intel Foundry Alliance, Synopsys commits to offering the design services, so in addition to the optimization EDA tools and IP. So to help customers accelerate their advanced chip designs as long as founding members of a new Intel Foundry Chiplet Alliance, Synopsys will further enable interoperability and manufacturability and design solution supporting the multi-die chips on Intel 18A. The additional resources Synopsys is exhibiting and speaking at Intel Foundry Direct Connected today in San Jose MEC Energy Convention Center, booth number 35. For more information, visit the Intel Foundry Direct Connection event page. About Synopsys, catalyzing the era of the pervasive intelligence, in Synopsys Incorporation delivered trusted and comprehensive silicon to design system design solutions from electric design automation to silicon IP silicon IP and system verification and validation. We partnered closely with semiconductor and system customers across a wide range of industry to maximize their R&D capability and productivity, so powering innovation today and ignite the ingenuity of tomorrow. So next one is NVIDIA's asked U.S. government to ease AI GPU export rules, but the Trump administration plans tighter control. The chip access could be used to negotiate trade deals. The NVIDIA and CEO Jensen Huang has once again called the U.S. government to revise the previous administration's AI processors export restriction, arguing that these regulations hinder the American companies from fully participating in global markets, according to a report from the Bloomberg. However, the current administration seems to disagree, as it plans to further restriction export of AI GPUs, so we can use them as barring the chips when negotiating trade deal with our other nations, according to the Reuters. I'm not sure what new AI diffusion rule is going to be, but whatever happens to be, it really has to recognize that the world has changed fundamentally since the previous AI diffusion rules was released, Huang said at the Hill and Valley Forum, where the business leaders and lawmakers gather to discuss the technology and national security, according to Bloomberg podcast. We need to accelerate the diffusion of American AI and technology around the world, so policies and encouragement from the administration really need to be behind that. According to the AI diffusion framework introduced by the Biden administration, access to advanced AI chips such as NVIDIA H100 is generally unrestricted for companies based on the U.S. Tier 1 nations, a group of 18 alliance nations. Those located in Tier 2 nations face an annual limit capped at a roughly 50,000 units of H100 class processors, unless they obtain verified the usual VEU approval. However, firms from the Tier 2 regions can import up to 1,700 units per year without requiring an export license. These smaller purchases do not account toward the 15,000 unit national cap. For countries under arms embargoes, Tier 3, including China, Russia, and Macau, really our shipment from the advanced AI processor effectively barred. The Trump administration is currently evaluating this tiered structure to enhance its clarity and enforceability. The NVIDIA had criticized Biden's AI diffusion rule, saying the restriction of American GPU export will support development and proliferation of computing hardware, software, and standards, specifically these development in China. Therefore, the NVIDIA and its CEO has been advocating for change. While the Trump administration agreed that the change is needed, it looks like it may not be changes NVIDIA and other American hardware developers are hoping for. So under the proposed revisions, the tiered model may be replaced by old global license regime, removing the former agreement and between the government and this would enable the U.S. to negotiate access on a case-by-case basis. Giving the U.S. government more leverage in trade discussion, officials are also considering a change to a volume of chips can be exported without a formal approval. Currently, shipment of the less than 1,700 H1 class units can be made with Omni notification. This threshold may be lowered to 500 units. Former U.S. Secretary of Commerce Wilbur Ross confirmed that this approach is under consideration, though unknown decisions have been finalized, according to Reuters. If new rules operate, NVIDIA's success will depend not on the capabilities and performance of each GPUs, but rather than trade deals linked between U.S. government and other nations. Needless to say, at least some nations might prefer deal with China's Huawei, which is just behind NVIDIA, according to the Huang. China is not behind anybody. China is right behind us. We are very, very close, Huang said. There is no question that Huawei is one of the most formidable technology companies in the world, and they are incredibly competing. They are incredibly in networking technology and in software capabilities. All of those essential capabilities to advanced AI, and they've made an immense process in the last several years. Okay. Today, also thank you for your time and see you next time.